Hey friends, so now we're going to talk about the most important category of window functions for data analytics. We have the value functions, or sometimes we call them window analytical functions. So here we're going to cover 4 different functions. We have the lead, lag, first value, and last value. And as usual, we're going to learn the concept behind them, how SQL execute them behind the scenes, and then we can learn the syntaxes, and we're going to cover the most important use cases for the value functions that I collected from my projects. So now let's start with the first question. Why do we call them value functions? So let's go. Alright everyone, so now we have this very simple example. We have the months and the sales. Now we can use the value functions in order to access a value from another row. So in order to understand it, let's say that SQL now processing the months and we are currently at the month of March. So now for example, I would like to access the value from the previous month, from February. So in order to do that, we can use the lag function in order to get the value of 10. So with that, we have in the same row the current sales of the month March and as well the sales from the previous month, the February. And maybe in other cases, I would like to get the sales of the next month from April. In order to do that, we can use the function lead and we will get at the same row the value 5. So now I can very quickly compare the current month with the previous month and as well with the next month. And now in the other cases, you might be interested in the first month of your list. So it's going to be here, January. So in order to get the sales of the first month, you can use the function first value. So we're going to get at the same row 20. And now for the last option, I think you already get it. We can go and get the value of sales of the last month. So here we can get the July. So for that, we're going to use the function last value and we will get the value of 40. So this is exactly the purpose of the value functions or analytical functions. We can access a value from another rows. And here it's very important to understand as well, the value functions is like the ranking functions. We have to use the order by in order to sort the data, in order to understand what is the first row and the last row. In this example, the data is sorted by the month. So guys, the access functions are really important for analytics. You can use it in order to access a value from other rows in order to do comparison. Alright, so now let's have a quick overview of the syntax and the rules for the value functions. So here we have 4 functions: lead, lag, first value, and last value. So as you can see, we can group them into 2 groups. So we have the lead and lag. They are very similar to each other's, especially with the syntax. We can use 3 things or 3 arguments inside it: expression, offset, default. For both of them, for the first value, we can use only an expression. So that means we have to pass and value for those functions. You cannot leave it empty. So now about the expression data type, you can use any field with any data type. There is no restrictions about only, for example, using numbers. Any data type is allowed. Now about the definition of the window, the partition by as usual is optional like any other group. The order by here is a must. You must define an order by. It's like the ranking. So here you cannot leave it empty. Now we come to the last one. We have the frame clause. They are really different stuff over here. So for the first 2 functions, lead and lag, you are not allowed to define any frame. So you are not allowed to define any subset of data. It's very similar to the ranking. So you must use order by, but you cannot define the frame of the window. But for the other 2 functions, the first value and the last value, they are optional. You can go and use them. And for the last value, it is recommended to define a frame clause. Don't worry about it. We're going to have enough examples in order to understand. So as you can see, those functions has different requirements. So there is no generic rule for all of them. But one thing that they all agree on, that you must use order by. So now as usual, what we're going to do, we're going to go and deep dive into those functions. We're going to address first the 2 functions lead and lag because they are very similar to each other's. We can understand the use cases, when to use them, and of course we're going to practice in SQL. So let's go. Lead and lag functions. The lead function can allow you to access a value from the next row within a window, where the lag function is exactly the opposite. It can allow you to access a value from a previous row within a window. It sounds very easy, right? So let's understand how SQL gonna execute those functions. Okay, so now let's have a quick overview of the syntax for both of the functions lead and lag. We have here a very simple example for the lead function. So as usual, we start with the function name. It's gonna be the lead. And now after that, we're gonna go and pass the arguments. And as you can see, we have here multiple stuff. So let's do it step by step. So the first thing is that we're going to go and specify an expression, and the data type could be any data type. It could be a number like here, the sales. It could be a character like names or dates or anything. So this is required. We have to specify an expression. We cannot leave it empty, and we can use any data type. Now moving on to the next one, we have here a number. So what is it? This is the offset, and this offset is optional, so you can go and skip it. So what offsets means, what we are doing over here, we are specifying for SQL the number of rows forward or backward from the current row. So here in this example, we are specifying the offset as 2 using the lead, and with that we are telling SQL, go jump to the next 2 rows and get me the value. And if you are using lag, it means you are telling SQL, go back 2 rows up and get me the value. So here you are telling SQL how many rows it needs to jump. And if you don't specify anything, like leave it empty, SQL gonna go and use a 1. So the default of this, so the offset is gonna be 1 if you don't specify anything. Alright, moving on to the last one and to the third one, this is as well optional. You can go and leave it empty. So here it is the default value. Now what happens with those functions is that sometimes SQL jump to the next 2 rows or something like that, and SQL doesn't find anything. So there is no more rows available to access. And with that, SQL gonna go and return a null. So that means if SQL goes to the next rows or go to the previous rows and doesn't find anything, SQL as a default gonna go and return a null. So if you don't specify anything over here, in those scenarios, you will have a null values as a return from the whole function. But in some scenarios, you don't want to have a null. You would like to have a value. So here you are defining the default value. So it should not be a null, it should be a 10. So SQL, if you don't find anything, return a 10. Don't return a null. So again, guys, the default values, the offsets, all those informations are optional for you in order to configure it, but you should know the default. If you don't use anything, for the offset it's going to be 1, for the default value going to be null, but you must specify an expression. So here you cannot leave it empty. Alright, so that's all about the arguments that you can pass to the lead or lag functions. Then the next stuff are the standard stuff. So we have the over clause, then we have the partition by. As usual, partition by is optional. And then to the order by, those functions, it's like the rank functions, it requires you to sort the data. So it is a must to sort the data, otherwise SQL will not know what is the next row, what are the previous rows. So we have to sort the data, it is required, you cannot skip this, so it is not optional. Alright, so the syntax is not crazy, right? We have the usual stuff, but only we can go and configure the default value and the offsets. Okay guys, now we have a very simple example. We have months and sales, and we're gonna go and understand how the SQL works for both of the functions, lead and lag, side by side. So now in the first example, we are interested in the sales of the next month. So in order to do that, we're going to use the lead function. So lead, and then we're going to specify the argument. It is the sales. We want the value of sales. And then we define the window like this, order by month. So it's going to be ascending. And now in the right side, we're going to be interested in the sales of the previous months. So in order to do that, we're going to use the lag function. So it's going to be very similar to the lead. We have lag and then the sales, since we are interested in the sales, and we're going to sort the data by the month. So now let's see how SQL going to do it step by step and side by side. So SQL going to start with the first. So now let's see how SQL going to process those informations side by side and row by row. So it's going to start with the first row over here. What is the next month of January? It is February, and we are interested in the sales of this row. So SQL gonna take the value from the next row, and we're gonna have the value of 10. So now by looking to the January, we can see the sales of the next month of February in the same row. So now let's check the right side over here. Now we are interested in the previous month. So what is the previous month of the first row? It will be nothing, right? So we cannot point it with anything. That's why SQL gonna say this is null. There is no previous month for the current row, and we're gonna have it as a null. Okay, so now SQL gonna go to the next row. We are at February. What is the next month? It's gonna be March, and it's gonna point to it. So we will get the 30 as the sales of the next month of March. And on the right side, what is the previous month of February? It's gonna be January, right? So it's gonna get the value, the sales of the previous month, and here we will get 20. So as you can see, it's very simple. On the lead, we are always checking the next values. On the lag, we are always checking the previous value. So let's keep going. We are currently at March. What is the next month? It's going to be April. So SQL going to go and point to it like this, and we will get the sales of the next month, April. For the March on the right side, what is the previous month? It is February, right? So it's going to go and point to February. So we will get the sales of 10. And now interesting to the last row over here, you can see that we are at April. What is the next month of April? There is nothing because we are at the end of our table, right? So since there is no month after that, we will get a null in the output. But for the lag, we still have a previous month for April. So what is the previous month? It is March, and we will get the sales of the March. So it's going to be 30. So that's it, guys. It's really simple, right? It's just like they are doing the opposite things. So now, if you check those values side by side, you can see that with the lead, we will always get a value for the first row, but for the last row, it's going to be always empty because there is no next value. We are at the end of the table. But if you check the lag, for the first value, we will always get a null because there is no previous value or previous record from the first row. And for the last record, as you can see, we're always going to get a value because we will have a previous value. Okay, let's move on in order to understand how SQL this time works with the offsets and the default value. So now we have the same data, but we have different tasks. So now on the left side, we would like to get the sales of 2 months ahead. So it's not the next month, it's going to be 2 months. And we would like to tell SQL, if you don't find any value, don't return null, return for us is 0. So this is going to be our default. Now, if you check the syntax, it's going to be exact like before, but we are adding now an offset of 2 because we are interested in 2 months ahead, and we are specifying here a default value 0. So if you don't find anything, put 0, don't put null. Now on the right side, we have the exact opposite. We are interested in the sales of 2 months ago. So we are not interested in the direct previous month. We need the sales of 2 months ago. And here the same thing. If you don't find anything, don't return null, give us a 0. So as you can see, we have the same syntax, but using the function lag. So now let's understand how SQL can execute this step by step and side by side. So SQL gonna start with the first month, January. So now SQL gonna ask, what is the sales of 2 months ahead? So we are at January, it will not be February, it's going to be the month of March. So it's going to go and point it like this, and we will get the value of 30. So 30 is the sales of 2 months ahead. And now on the right side, we are as well at January. SQL can ask the question, what is the sales of 2 months ago? So we don't have any previous data, right? So we will not get anything. SQL going to return null, but it's going to check, do we have a default value? Well, yes. So this time SQL will not return null, it's going to return the default value, and this time it's going to be 0. Alright, so now let's go to the next value. We are currently at February. What is the sales of 2 months ahead? So it will not be March, it's going to be April. So it's going to go and point it like this, and we will get the value of 5. So now on the right side, we are currently at February. Now the question is, what is the sales of 2 months ago? We have history, we have the previous month, but we don't have 2 months in the history. That's why we will still get 0 at the output with the default value. Okay, so now let's keep going to the next value. We are currently at March. SQL can ask, what is the sales of the 2 months ahead? We have only 1 month after that, but we don't have 2 months. That's why SQL will not find anything, and it's going to return null, but it's going to go and use the default. So here we're going to go and get the value of 0. There is no more data available in the table. But now on the right side, we are currently at March, and we are asking what is the sales of 2 months ago. So now we have enough history in the past, and it's gonna get the value of 20. Alright, so now let's go to the last month over here in our table, April. What is the sales of 2 months ahead? We don't have any data, so it's gonna be 0 as well. But now on the right side, we are currently at April. What is sales of 2 months ago? We have enough history. That's why SQL gonna get and point it like this. So we will get the February, gonna be 10. So that's it. This is how SQL works with the lead and lag using offsets and as well default value. Let's go back in SQL in order to practice those 2 functions. Okay, so now we have the following task, and it says analyze the month-over-month performance by finding the percentage change in sales between the current and the previous month. So that means we have to go and compare the current month with the previous month. So the main use case for the lead and lag is to do comparison analysis, and we have a very common use case. It's called time series analysis. So it is the method of analyzing our business, our data, in order to understand the patterns and trends over the time. And one of the most important and classical questions that you're gonna get from the decision makers or business is to do year-over-year analysis or month-over-month analysis. So the year-over-year analysis is gonna help us in order to understand the overall growth or decline in the performance of our business over the years, over the time. But in the other hand, we have month-over-month analysis in order to do short-term trends analysis and as well discover the patterns in the seasonality. So the main focus is to understand the performance of our business over the time. So now let's go back to SQL in order to solve the task. Okay guys, so now let's go and do it step by step. Now, what is the first step? Before we go and compare things together, we have to collect the data. We have to do the calculations first. So we have to find out first the total sales for the current month and then the total sales for the previous month. And after that, we can go and compare them. So now let's start with the easy stuff. We have to find out the current sales for the current month. So in order to do that, let's just do very simple select. So what do we need? Let's take the order ID. Let's take the order date because inside it we have the month. Let's go and collect the sales. So that's it for now from sales orders. So let's go and execute this. So now on the result, we got the usual stuff. We have 10 orders, sales, and order dates. But the order date is on the level of the days. And we are not interested on the whole date. We would like to get only the month in order to calculate the total sales for the month. Now we're going to go and use a function in order to extract the month from a date. Don't worry about it. We're going to have a dedicated chapter in order to show you how to deal with the dates format in SQL. So now what we're going to do, we will use a very simple function called month and order date. Let's call it order month. So that's it. Let's go and execute it. Now, as you can see, we got a new field where we have only the month of formations. So here we have January, February, and March. So now the next step is that we want to find the total sales for each month. So what we're going to do, we're going to go and use group by. So let's do that. We're going to go and say we want the sum of sales. I'm just going to call it current month sales. And let's go and get rid of all those informations. We're going to go and group by the month, right? So group by, let's have the month. So that's it. Let's go and execute it. So it's very simple, right? We got now the 3 months and the total sales of the current month. So now with that, we got the first information that we need in order to do the comparison. We have for each row the total sales for the current month. So now the next thing that we're gonna do is to find out the total sales for the previous month, like side by side in the same row. And in order to do that, we have learned we can go and use the lag function. So we're gonna go and integrate the lag window function in the same group by. So we're gonna do it like this. So lag, we are now interested in the previous month. So that's why we're gonna go and get the sum of sales as an expression inside it. And after that, we're gonna define the window. It's gonna be like this over, and order by is a must. So we're gonna go and sort the data by the month, right? So let's go and do it. And with that, we have defined the previous month sales. So you are the previous month sales. So now let's go and execute it in order to see the results. Alright, so now let's check the results. The first row, what is the previous month? There is no previous month. We are at the first record and the first month. That's why we have null. Now let's go to February. What is the sales of the previous month from January? It is 105. So this is correct. And now to the last value, to the March, what is the sales of February, the previous month? It is 195. So with that, we got the two informations. We have the current month and as well the previous month. So guys, as you can see, it's magic, right? It's very simple. We can go and use the lead and lag functions in order to access another values from another rows without doing any complicated joins and so on. Okay, so now what is the next step? We're gonna go and subtract the total sales from the current month with the previous month. So in order to do that, we're gonna go and use a subquery like this. So select star from, and we're gonna have it like this as subquery. And now the calculation is very simple. Let me just move this a little bit down. So it is the current month subtracted from the previous month. And let's go and call it month over month change. So that's it. Let's go and execute this. So now let's go and check the results. For the first month, you can see that we don't have any value, and that is correct because the previous month is empty, so there is no change. And now moving on to the February, you can see over here we got plus 90. That means we have here improvement in the performance of our sales. Now moving on to the last one, it's really bad. We have decline in our performance. We can see that we have minus 115. So that means the current month is doing really bad compared to the previous month. So the March is really bad month. Okay, so now as you can see in the output, we got the absolute numbers, but the task says find the percentage change. So we have to convert this to a percentage, and we can do it like this. It's very simple. Let's do it in a new column. Just gonna zoom out a little bit. So it's gonna be the change, the differences divided by the previous month's sales, and then let's go and multiply it with 100 in order to get the percentage. So like this, and now as you can see we got zeros, and that's because those numbers are integer. So we have to go and cast one of those values. Just gonna do it for the first. So cast, and you are float. So that's it. Let's go and execute it again. Now the result looks better. We have the percentages, but we have a lot of decimals. So let's go and round the number to, let's say, 1 decimal. So only 1, and let's give it a name. So you are month over month percentage. So let's execute. So now as you can see, things get better, and with that we have calculated the percentage change in sales between the current and the previous month. And this is how we do month over month analysis. Alright, so now we have another use case for the lead and lag function. We can use them in order to do customer retention analysis. It's all about measuring the customer behavior and loyalty. So we are helping the business and decision makers to build strong relationship with the loyal customers, and for them as well to focus on their needs. So now let's see how we can use lead and lag function in order to do customer retention analysis. So let's go. Alright, so now we have the following task, and it says, in order to analyze customer loyalty, rank customers based on the average days between their orders. So there is a lot of things going on over here. Let's do it step by step, and I would like always to start with a very simple select. So let's go select informations like the order ID. Let's get the customer ID, and as well, since we want the days, we would like to have the date. So order date from the table sales orders, and let's go and sort the data. So order by customer ID and order dates. So that's it. Let's go and execute. So now as usual we got our 10 orders, the customers, and when they did order. So now let's check the task. Let's solve this over here. Days between their orders. So we have to find how many days are between two orders. For example, if we check the customer number 1 over here, he did order around 10 January. And the second order is like after 10 days, 20 January. So we have to go and subtract those two dates. Now, in order to subtract those informations and do calculations, we have to have everything in the same row. So for example, if we are at the first row over here, I would like to have as well one column about the next order. So the date of the next order. So we have to access a value from another row. Of course, we can go and do joins, but we have lead and lag functions. And for this scenario, we're going to go and use the lead window function. So let's go and do that. I'm going to go and call the order date over here as a current order, and let's go and calculate the lead. So I would like to get the next order date. So I would like to get this value over here in the same row. That's why this time we're going to get the order dates. And now let's go and define the window. Now we have to go and partition the data because we are analyzing each customer separately, right? So that's why we have to partition that by the customer ID. And of course, in order to do the lead, we have to use the order by. So let's go and define that as well. Order by, and it's going to be by the order date. So now we have to give it a name. The order date here is the current order. This is going to be the next order. So next order. Let me zoom out a little bit and make this smaller. So let's go and execute it. So now as you can see in the output, we got a new column called next order. And with that, we got the current order, the current row, and as well the value from the next row. So what is the next row? It's going to be the 20 January. The same thing, of course, for the next row over here. We have the current order date and the next order date. So this value is going to be exactly as the next one over here, 15th of February. And then since we are working with windows, this is the whole window over here. The last order for this customer it's 15th of the February, there is no next order, so this is gonna be null. The same thing if you check the other customers, you can see always the last order don't have any next order. So looks like everything is fine. And for the last customer, he has only one order. So now with this, we got all the informations for our calculations. So we have the current order and the next order in the same row. Now we can go and subtract them in order to get the days between those two orders. And now in order to subtract date, we have to use the function dateDiff. Don't worry about those functions. We're going to explain all those stuff in the next chapters. So now just follow me with those steps. What we're going to do, we're going to go and subtract this date, the order date, with the whole thing over here, right? So the whole thing here is the next order. So let's do it in a new line. And it's going to be very simple. So dateDiff, we are finding the differences between two dates. So the syntax is going to be like this. First, we have to define what we are talking about. Are they days, months, years, and so on? So we have to tell SQL, find me the differences in days. Now we have to specify 2 days. So the first one gonna be the order date. This is the current date. And the second date gonna be the whole thing from here. So let's take it and put it side by side. And this calculation gonna give us number of days. So we're gonna call this days until next order. Alright, so now let's go and execute the whole thing. So now let's check the result. As you can see over here, we got 10. So this is 10 days between those two dates. And the next one, we have around 26 days. Here we have a null because we don't have here a date. And for the next one, we have 31 days. So we have a whole month over here. So everything is working perfectly. And with that, we have solved only this part. Days between their orders. So guys, you see, right? This is the magic of the lead and lag function. We can very easily access any information you need in the same row in order to do such an important analysis. And with very simple query, we are not doing any crazy stuff like joining and stuff. We are just specifying the lead function. So now we got all the informations that we need. Next, we're gonna go and calculate the average of those days. So in order to do that, we have to go and use a subquery. So let me just zoom out. So let's go and select star, just prepare the subquery. So the whole thing gonna be a subquery. I'm gonna just get rid of the order by, it's not now necessary. So let me just put it like this and shift it. So now what do we need? We need the average of the days. So we need the average of this value. So what can we do? We're gonna go and use a group by. So customer ID, since we have to find the average for each customers, and we're gonna get this value and say average days until the next order, and we're gonna call it average days. So, and we have here to group by, so group by customer ID. So like this, just make this a little bit smaller and zoom in here. So that's it. Now we are just doing a very simple average and group by statements. So let's go and execute it. Now, as you can see, SQL can go and aggregate the data. So we have now only 4 customers, and for each customer, we have the average days between their orders. So now what is missing in our task? If you check over here, it says rank the customers based on this average. So we have to go and use the rank function. So here again, another window function that we have to go and use. We're gonna do it together with the group by. So let me just make this a little bit smaller, and then let's do it over here. So I'm just gonna go with the rank function. Then we're gonna define the window like this over order by, and then we're gonna go and sort the data by the average days. So that means we're gonna go and get this calculation over here and put it as order by. It's gonna be ascending, so we are focusing on the lowest average days. So that's it. Let's call it rank average. So now let's go and execute this. So now by checking the result, you can see now we have a ranking for the average. And here SQL says that the number 1 customer, or the number 1 loyal customer, is the customer number 4, which is not really correct, because the number 4, we don't have a lot of information about this customer. He or she did order only once. So either now you go and like filter the data and remove this customer, where you say if the average is null, then don't put it in the rank, or we can go and replace this value with a very huge value in order to make it at the end of our list. For example, we can go over here and replace the null with qualisk like this, and we say if the average is null, then let's say give me a crazy number like this, very huge one. So that's it. Let's go and execute. And now as you can see, this customer is going to be at the end of our list. And now we can see that the most loyal customer is number 1. And then the other 2 customers are in the rank 2. Here we are sharing the same rank since we have the same average. So guys, with that we have solved the task and we have ranked the customers based on the average days between their orders. So we have now a really nice rank and we can understand now the behavior of the customers, and maybe we have to go and focus on the customer number 1 and understand her or her needs. And of course, the function that helped us here in order to do such a customer retention analysis is the lead function in order to find the next order to calculate the days. So this is how you use lead functions to do such a use case. The first value and the last value functions, I think the name says everything, right? So the first value can allow you to access a value from the first row within a window, where the last value, exactly the opposite, it can allow you to access a value from the last row within a window. Easy, right? So now let's understand how SQL execute those functions. Okay, so now as usual, we have this very simple example. We have the months and sales, and we have it twice because we would like now to go and compare side by side the 2 functions, first value and last value. So now for the left sides, we would like to get the sales of the first month, and on the right sides, we would like to get the sales of the last month. So now for the first task, we can go and use the first value. It's very simple. So the first value function, then the argument going to be sales since we want the sales. And then the window going to be defined like this, order by month, because we want to get the first month. So as usual, we must use order by. Now on the right side, in order to get the sales of the last month, we can go and use the last value, right? So the same things, last value sales over order by month. So as you can see on the left and right, we don't use any frame definition, but the default going to be used from this. Alright, so now let's see how SQL going to process both of those queries side by side. So the first step, SQL going to go and sort the data. They are already sorted from the lowest to the highest. And then the next step is going to start row by row finding the first value on the left side. So what is the unbounded preceding? It's going to be static and always pointing to January. So this is always going to be the unbounded preceding. We have it in both sides like this. And what is the current row? It's going to be at the start, the first row. And on the right side, the same things over here. So the window definition gonna be is only 1 row, right? So what is the first value in this window? It is 20, right? The same things on the right side. What is the last value in this window? It is as well 20. So we will get exactly same results. Now let's move to the second row. So it's going to be pointing to February, and the frame definition going to be here extended like this. So what is the first value in this frame? It's going to be as well 20, right? So in the output, we're going to get 20. And now in the right side, the current row going to be as well pointing to February, and the window gonna go get extended. So now what is the last value of this frame? It's gonna be 10. Now let's keep going. We're gonna go to the March, and the window gonna get extended. What is the first value? It's always gonna be the same, so 20. On the right side, window gonna get extended. What is the last value? It's gonna be 30. So as you can see, the default definition is always having the static start, always the same start of the subset. And as we are moving with the current row, the frame gonna get extended. So now moving to the last one. And with that, we will get the whole dataset inside the frame. And the first sale is gonna be 20. On the right side, the same things gonna get extended like this. And this time, the last one gonna be April and 5. So now if you go and compare them side by side, you see that on the left side, the task is solved and everything is working correctly, right? So we have for each row always the sales of the first row. And what is the first row? It is January. So we have everywhere a 20, which is correct. But now if you check the right side, you can see there is something wrong, right? We are getting not the last value. We should always get April, right? We should have here everywhere a 5. So we have here exactly the same result as the sales. So it's really useless to use it like this, right? And that's of course because SQL is using the default definition of the window frame. Last value is the only function from all window functions that you cannot use the default frame definition. You have to go and customize the frame definition in order to get the effect of the last value. For the first value, everything is working if you are using a default frame, if you are not specifying anything. But for the last value, you will not get the effect correctly without customizing the frame window. So my friends, you can go and use the first value function like all other window functions without defining a frame. You can go with the default and you will get the effect of the first value, but the last value you have to go and define a frame. So let's see how we can solve that. Alright, so now in order to solve this, we're gonna define the frame like this. It's gonna be the rows between the current row and the unbounded following. So we just switch things around. So now let's see how this can work. Now of course SQL gonna go and sort the data and so on. Now SQL gonna have a pointer to the unbounded following, so it's gonna point always to the last row in our dataset, and then it's gonna proceed step by step. So the first row gonna be like this, and the frame gonna be the whole thing, right? So from the current row until the unbounded following. So what is the last value? The last row, it's gonna be the 5, right? The April. So we will get in the output 5. Now let's proceed to the next value. The frame gonna be shorter and smaller. And what is the last value? It's gonna be as well the 5, right? So now we jump to the next one, and the frame gonna be like this. What is the last value? As well 5. And then we will get the last value like this. Current row is equal to the unbounded following. We have only one row and it's going to be as well 5. So as you can see, it's very simple. Just fix the frame clause and you will get the last value working as expected. So this is how SQL going to go and do it. Now let's go back to SQL and start practicing. Alright, so now we have the following task. It says, find the lowest and highest sales for each product. So now let's see how we can do this. As usual, we're going to start with very simple select statements. So select order ID. We need the product ID and as well their sales. So let's select the table, sales orders. So that's it. Let's go and select this. Now in the output, we got our orders, product and sales. So now let's start with the first part of the task, find the lowest sales for each product. So in order to do that, we can use the first value function. So let's go and do that. First value. Then what we are talking about, we have to give an expression. We need the lowest and highest sales. So let's go and have the sales inside it. And now we have to define the window. So over, since we are saying for each product, that means we have to go and make windows. So we have to divide the data using partition by product ID. And then we must use an order by, right? So we have to go and sort the data by the sales. Since the first value should be the lowest value, we have to do it as ascending from the lowest sales to the highest sales. So we're just gonna leave it like this as a default, and we're gonna call it lowest sales. So let's go and execute this. So now let's go and check our results. First, SQL gonna go and partition the data by the product ID. So as you can see, we got now here 4 windows, then sort the data by the sales. So the data are sorted from the lowest to the highest, from 10 to 90. So now what is the first value of the sales? It is the first row, right? So it's gonna be 10. That's why we have everywhere a 10. Let's check another one. Let's take this one here. So this window has 2 rows and it is sorted. The lowest sales, or let's say the first value, is 25. So with that, we have solved the first part of the task, finding the lowest sales for each product. Let's go to the next one. We have to find out the highest sales for each product. So let's go and use the last value for this. So let's have a new line. We're gonna have a last value. Again, the sales. Then we're gonna go and define the window. So it's gonna be the exact same window. We have to partition the data by the product ID and order the data by sales. So let's go and just copy the previous one. Let's call it for now highest sales. So let's go and execute it. So now if you check the results, you will see our issue over here again, right? We are not getting the highest sales for this window. The highest sales is 90, but as you can see, we are getting the exact same sales, and we have explained that in the previous example. So in order to fix this, we're gonna go and add for it the frame. So rows between current row and the unbounded following. So now let's go and execute this. So now let's check the result. As you can see over here, we got the highest sales correctly. So for this window, the highest one is 90. And as well for this window, the 60 and so on. So with that, we have solved both of the tasks, the lowest and the highest sales. But now I would like to show you my honest opinion about these tasks. I will not go and use the last value to find the highest sales. So let me show you how I usually do it. I'm gonna go and use the first value in order to find the last value. So now let me show you what I mean. Let's go and add a new row. I will just take the whole thing from the lowest sales, But what I'm gonna do, I'm just gonna go and change the order. So that means we will not go and sort the data like this, ascending from the lowest sales to the highest sales. We're gonna go and switch it. So we're gonna go and sort the data from the highest sales to the lowest sales. And with that, the first value gonna be the highest sales. So let me just rename it. Highest sales, let's give it like 2. So let's go and execute this. And now you can see over here, we got the exact same results because we sorted the data differently and we get the first value. So this is going to give you the exact same effect like the last value. And as you can see, I don't have to define now any window or something like that. I can stick with the default frame, but just twisting the order by. So this is how you can do it as well, using only the first value. So now just for the sake of this task, there's as well another possibility in how to solve this. You can go and use the min-max functions. So let me just take the same and have a new one, the lowest sales. We can go and say, you know what, let's get the min. So we are saying, find me the minimum sales, and we don't have to go and sort anything. So we can go and just divide it like this. So let's give it another ID. Let's go and execute it. So as you can see, we got the exact same results like the other two highest sales. So as you can see, we can solve this task using 3 different functions. Either go and use the last value, but you have to define the frame, or you can go and use the first value where you switch or flip the order by, or simply just using the max function in order to get the highest sales. So guys, as you can see, we can use the first value and the last value in order to find out the extremes, like here in this example, the lowest and the highest sales. So there is like similarity between those two functions and as well the min and max. And of course, what we're gonna do with this value over here, we can go and compare it with the current sales. So for example, we can go and extend our task where we say find the difference in sales between the current and the lowest sales. So in order to do that, let me just clean up all those stuff. Let's stick with the first value and the highest value like this. So we have to compare now the current sales, which is this field over here, the sales, the original one, with the lowest sales, with the whole thing from here. So let's go and do that. So we're gonna have a new line and we're gonna say, just simply subtract the sales from the lowest sales. So like this, and let's give it a name, sales difference. So that's it. Let's go and execute it. Now, as you can see in the result, in one row, I'm comparing the current sales, which is 90, with the lowest sales from this product. It's going to be the 10. So with that, we're going to get the distance, let's say, between those two informations, and it's going to be 80. So now for the next one, the distance between this value and the lowest value is shorter. So we are near the lowest value. So as you can see over here, we can now compare the sales between the current sales and one extreme in order to find the distances between two values. So this is again a very important analysis in order to do comparison analysis. Alright friends, so now let's do a quick recap about the value functions, or we call them sometimes analytical functions. So what they do, they're gonna go and allow you to access a specific value from another row. This is gonna help you in order to do complex calculations with very simple SQL without having you joining tables together or doing self-joins. And for the value functions, we have 4 types, or let's say 4 functions. The first one allows you to access the previous value, like the previous month, using the lag function. The next one, it allows you to access the next values, the next month, using the lead function. Then we have another one, it allows you to access the first value in a subset using the first value function. And another option, we can go and access the last value in a subset using the last value function. Moving on to the next one, we have the rules of the syntax. So about the first point, it is the expressions. We can go and use any data type. It could be a number, string, a date, anything. Now, in order to perform those functions, we have to go and sort the data by the order by. So order by is required, it is a must. Then for the frame, you are allowed to use it, so it is an optional thing. I would say always leave it empty for the frame, but only for the last value you have to go and customize, otherwise it will not work. Now to the next point, we have the use cases. we have simply very important use cases for the value functions in data analytics. So what we can do time series analysis. As we learned, we can do month-over-month analysis and year-over-year analysis. Those analyses are classical, and it's always the first question in data analysis in order to measure, are we growing with the business or are we declining? How the performance between the current year and the previous year. So as you can see, we are doing always comparison using those window functions. The next use case is as well about the time. We can do time gap analysis as we analyzed the customer behavior, the customer retention, where we have calculated the average days between two orders. And the last use case, it's as well about comparison analysis. We can go and use the value functions in order to compare the current value with extreme, like comparing the current sales with the highest sales or to the lowest sales. So my friends, those analyses are essential in data analysis. You will be countering them in each company, in each business. You have to answer those questions, and you can do that very easily using the SQL window functions. Hey friends, so finally we have covered everything about the SQL window functions and their amazing use cases for data analysis. I promise you, you're gonna use those functions in real projects. And now moving on to the next chapter, we're gonna focus on the SQL set operators. They are very powerful in order to compare and combine your data sets. If you like this video and you want me to create more content like this, I'm gonna really appreciate it if you support the channel by subscribing, liking, sharing, commenting. All those stuff gonna help the channel with the YouTube algorithm, and as well my content gonna reach the others. So thank you so much for watching, and I will see you in the next tutorial. Bye.